everyone, I hope you all are doing good, and I'm very happy to announce that I'm going to start this new series called Data Structures and Algorithm. In today's video, we will be discussing about what a data structure is and why do we need them, what is an algorithm, is there any relationship between data structure and algorithm, and also some examples. So without any further ado, let's just dive right into this video. First, let us understand what a data is. Data is a raw and unorganized fact that require to be processed to make it meaningful. Generally, data comprises facts, observations, perceptions, numbers, characters, symbols, images, etc. Data is always interpreted by a human or a machine to derive meaning from it. So, the data is a raw form, which is meaningless. For example, A is equal to 100. By looking at this value, we cannot derive a particular meaning, like why the value 100 is used here, whether it denotes the speed of a car or how much kilometer a man covered. So this is what I meant by data is meaningless in its raw form. So when does a data becomes useful? To understand that, we need to know what information is. We often use this term data and information interchangeably, but are they same? Let us find out. Information is a set of data which is processed in a meaningful way according to the given requirement. Information is processed, structured, or presented in a given context to make it meaningful and useful. It also involves manipulation of raw data. For example, we can convert our data A is equal to 100 to an information by adding kilometer to it, making it as an information. So we now know about data and information. How is it connected to data structure? We can understand this from the definition of data structure. Data structure refers to the way data is organized and manipulated. It seeks to find ways to make data access more efficiently. When dealing with data structure, we not only focus on one piece of data, but different set of data and how they can be related to one another in an organized manner. Some examples of data structures are arrays, graphs, and linked list, and much more. These data structures or these arrays or graphs or linked list acts like a container to store specific type of data. Now we know what a data structure is. But what is the use of knowing all these types of data structure? How does it help us? Well, by knowing these data structures, what we gain is efficiency. Some reasons why we need to use data structures are: first one, data search. Consider an inventory of 1 million items of a store. If the application is to search an item, it has to search an item in 1 million items every time. So every time what happens is this slows down the search operation as there is 1 million set of data that we have to search. This shows that as data grows, the search will become slower. The second point is processor speed. If data grows in billion records, even the highest speed processor will also fall. Third point is multiple requests. When thousands of users want to access the data simultaneously on a web server, no matter how fast the web server is, it will fail in searching the data if we did not use data structures. So these are the reasons that shows us why data structure is important or why we need to use them. Next topic, types of data structures. Python data structure is divided into two, built-in and user-defined. The implicit support for data structure, which enables one to store and access data, are built-in data structures. These data structures are list, dictionary, sets, and tuples. Python also allows us to create our own data structure, so that comes under the category user-defined data structure. The most known data structures are linked list, stack, queue, trees, and so on. We can also perform some basic operations on these data structures. They are insertion, deletion, traversal, search, and sorting. We will discuss each of these data structures in detail in upcoming videos. But why is studying different data structure is important? Why can't we just use the same data structure, for example, arrays, for storing all the data? We will see why we need different data structures with the following example. Suppose we store the gold rate for 4 days. What we want is that we want to access the gold rate for the first day and the 4th day. Since here accessing is sequential, we make use of list. Now let's use the same data, but this time we need to access it differently. That is, we need to store the gold rate between August 9 and August 13. And what if we need to access the gold rate on a particular date? That is on August 12 or August 10. So in this particular case, it is best to use dictionary, where the key of the dictionary will be the date and value of the dictionary will be the gold rate. Using this data structure, we can access the information that we needed in an efficient manner. These examples shows us how important it is to choose our data structure for different problems so that our ultimate goal, that is to achieve efficiency, is satisfied. Data structure is a conceptual thing. To implement this, we need a programming language. Data structure is implemented in different ways in different programming languages. For example, in Python, we does not have a standard library for linked list, but Java and C++ have them. We are done with data structures, right? So, what is this algorithm? Is there any relation between algorithm and data structure? Let's clear this confusion. An algorithm is any well-computational procedure that takes one or more values as input and produce some values as output. We can see any algorithm as a tool to solve a well-computational problem. When a problem statement is given, it specifies the desired input or output relationship. So, by using an algorithm, we can specify the specific computational procedure for achieving the desired input or output relation. Okay, I got the definition, but what is the relation between them? The data structures are the way to arrange data, as we have discussed earlier, so that some operations can be done on them. Whereas algorithm is a way to do something with the data in most effective way. That is, data structure helps the algorithm to achieve their goal in the most effective way. So let's discuss what are some qualities of a good algorithm. So, some of the good qualities that an algorithm should possess are: the steps should be finite and clear, it should take 0 or more input, must produce 1 or more output, it should be flexible, when analyzing it should give solution in optimal time, and the instructions in an algorithm should not be repeated infinitely. How can we write an algorithm? The 3 main steps of an algorithm is input, processing, and output. To understand how we can write an algorithm, let's dive into an example. Let us consider a problem statement. Find the sum of 2 numbers. Our algorithm for the problem statement is written as follows. The step 1 would be always start. Step 2, we read first number. In step 3, we read the second number. Here, step 2 and step 3 are input. In step 4, add 2 numbers, which is processing. In step 5, we display result, which is output. And step 6, which is mandatory, that is to stop the algorithm. That's it for today's video. Any queries regarding this topic, comment down below. I'll get to you as soon as possible. Thank you for watching. Make sure to like, share and subscribe, and also press the bell icon to get the notification of my videos. See you in the next video. Until then, take care. Bye-bye.